Right, let's do this, man.
Do it. That's my very bad written mail.
Theatre.
You're going to leave that in, aren't you?
Welcome to Terrible Lizards, a podcast about dinosaurs with Dr. David Home and Izzy Lawrence.
On this week's episode, the KT Extinction, why the dinosaurs died out, plus the Bad Astronomer Plait on death from the skies. Hello, and on this week's episodes, we're going to talk to you about death and destruction. It's my favourite subject. It's why I did geography. It's because I like a bit of death and destruction. Yeah. So we're going to talk about the extinction of the dinosaurs and how they all died off. Don't look outside at the pigeons. How they never survived.
Yes. Pay no attention to the birds behind the curtain.
Yes, just ignore the tweeting things and the chicken you ate for lunch. This is a subject which has had a lot of different theories come up in the past.
And rarely have they had any merit. I think it's also fair to say.
We can say categorically that the dinosaurs, the extinction event at the end of the Cretaceous period, is down to a meteor smashing into the Earth.
Yeah, some kind of bolide impact, I think, is the preferred phrase.
Well,
yeah, because there's subtle distinctions which I don't know between meteors, meteorites, asteroids.
Comets.
Comets are a different thing
Yeah.
again. Yeah, quite. And then so often it said, oh, it's a comet or it's a meteor or it's a meteorite, and these are all subtly different things. So bolide, I think, is just the catch-all term for something from outer space hitting the Earth. Yeah, that's ultimately what did it. I mean, there are
Okay, so we can stop listening now. That's it.
yeah, end of rah. There are lots and lots and lots still of subtleties and details and odd little contradictions in all kinds of bits of data about the extinction of the dinosaurs. That there are still lots of discussions being had, and there is lots more to come out. But I think it is pretty fair to say that no matter what else, everyone is happy with the idea that the terminal event, which ended the Mesozoic and brought to an end the age of reptiles, as it was called in the Victorian era, was just that. It is a tanking great chunk of rock, something around the size of either Mount Everest or New York City. I've seen both quoted. Very, very big. Travelling,
but not the size of Wales, which is what is usually the standard.
Which is or a football pitch. So yeah, it's somewhere. Yeah, it's not quite either of those.
Somewhere between a football pitch and Wales.
But yeah, so giant chunk of rock travelling, many times the speed of sound, so a colossal amount of energy, hit somewhere around the Yucatan Peninsula in the eastern seaboard of Mexico, and basically left a tanking great hole in the ground. And the local effect of this is obviously, the impact of something like this probably sets the air on fire. And then an air pressure wave that will kill everything for, who knows, 50, 100 miles in every direction, firestorm, earthquakes locally, tsunamis probably, if not globally, certainly the other side of the Atlantic, things like this, forest fires, yada, 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 yada. What's really doing the damage, though, is it's sending up a giant dust cloud into the atmosphere. That cuts a lot of sunlight out, that cuts out an awful lot of heat and light, that knackers all the plants, and if all your plants die, your herbivores and your carnivores and absolutely everything is going to go not too long afterwards.
But, okay, so all the dinosaurs die out, but they don't, because we've still got birds. And why did the mammals survive? Why is all of this?
Right, so as I say, there's lots and lots and lots of things to unpack. I mean, the first thing, actually, to dial back a bit, is there's a thing called the Deccan Traps. So this is a vast area of India. It's something like 500,000 square kilometres of volcanic ash and lava and stuff. And this was laid down right around the same time as the dating for the meteor impact, which is 65.5 million years ago.
Interesting.
And so for a long time there's been this discussion of, were the dinosaurs already on their way out? Because the Deccan Traps would have basically produced the same thing, a sufficiently giant ash cloud produced over hundreds of years, and there would be a sufficiently giant ash cloud if you could bury half of India in something like
Huge.
2 kilometres thick of of ash.
There's been a lot of volcanoes, and the amount of dust that they send up does have a huge impact on the climate. We think that there's theories about because the Bronze Age ended sort of 1200 BC, and they think that happened because there were a gigantic explosion in Iceland, that the dust went up into the atmosphere, and that caused crops to fail in Greece and in Cyprus and in all of that sort of bowl. And then you had this, the sea peoples, which were meant to be these, people attacking everybody and killing everybody. It was just refugees from different places looking for food.
Yeah.
The only civilization that survived, the end of the Bronze Age was the Egyptians, really. Anyway.
It's not the only one. So much more recently, we have the Tambora event in the early 1800s. So a single volcano in Indonesia blew up. And it was called the Year Without Summer. Basically, you were getting frosts in the UK in July, and crops failed worldwide. Supposedly, this is linked to some of the great painters like Turner, who were painting amazing sunsets right around then, which you get amazing sunsets if the atmosphere is absolutely clouded with dust for a few years. So we had a world freeze off one volcano exploding once. Imagine if basically half of India was a volcanic explosion for thousands of years. Oh.
I'm always very worried about Yellowstone Park, 'cause that
the
is
super
a massive
volcano.
super volcano just waiting to go. I mean,
Yeah, so without getting too sidetracked,
I like volcanoes.
What were the Deccan traps doing? There's this big discussion of basically were dinosaurs and indeed lots of other things already on their way out, and then the meteor was a bit of a coup de grace. Some people are very strongly in favour of this. Other people are far less strongly in favour of this. I think I don't really have a dog in this fight. It's not an area I'll work on. I think it's fair to say I think most people think the Deccan traps, or just in general, the dinosaurs were doing fine. There is some evidence that they had some population issues, fewer species, etc., but there's still good numbers of them pretty much right up to the boundary in most places that we look. And certainly there are big gaps. We just don't have many fossil localities right at the KT boundary. So that's KT is Cretaceous, but spelt with a K because the abbreviation C is Carboniferous. So the Cretaceous Tertiary boundary. Though now it's often called Cretaceous Permian boundary, and therefore it's KP. I know.
I just think everybody should imagine like an all-boys club where they only know one girl called Katie and won't let her in. There you go, the KT boundary. There you go.
Right.
Very Calvin and Hobbes.
There are lots of questions still about the bolide. There are lots of questions about the Deccan traps and dinosaur populations, but I think it is uncontroversial to say that everyone is pretty happy with the idea that whatever else was going on, the impact basically did for them. And as you say, not just dinosaurs. So we talk about the dinosaur extinction, and of course we do, and doubly so on Terrible Lizards, where it's a dinosaur podcast. But it's not just them. The pterosaurs go, the flying reptiles. Lots of the marine reptiles go. Ichthyosaurs, so the fish lizard, the very dolphin-like ones, had actually gone some time earlier, but the big plesiosaurs and pliosaurs, so the long-necked ones and then the big-headed ones...
The ones that's the Loch Ness Monster.
Isn't, yes. That one. So they go as well. All kinds of crocodile lineages took a hit. Mammal lineages take a hit. Birds survived. Lots of bird lineages went extinct. It's not like the birds sailed on serenely and did fine. They got a kicking as well. Coelacanths, which famously we thought it went extinct then, and then obviously popped up in the early 1900s off the coast of Madagascar. But they clearly took a hit, and it was a global extinction event. It's just we tend to talk about dinosaurs.
Cool. I mean, not cool, obviously. Terrible.
Pretty cool, actually.
To look at the sort of, the number of species before and after this event, I mean, how much of a decimation are we talking about? A decimation is obviously 1/10. It would be more than a tenth.
So it's very hard to say because obviously measuring species now is actually really tough. Measuring it 60-odd million years ago and then across a boundary, almost impossible. That said, we judge extinction events. So there's been 6 recognised mass extinctions in Earth's history, and this was the 6th one. And basically, to qualify as a mass extinction, you have to kill at least half of the species.
Okay.
So we're talking about half of species globally, we think, plus went extinct. So not bad, to say the least, in terms of your decimations.
Yeah, that's terrible. Okay, so why is it then? Why were dinosaurs particularly vulnerable to ultimately what is climate change?
Yeah, so they were, and so this kind of thing, really would be doom for them because, there's lots of different reasons that things do and do not survive extinctions. One of which is pure luck. If you just happen to be in the right little pocket where all the winds come together and means that you don't ever get much of the ash cloud, you could be fine. Or you're just tucked away on an island somewhere and no competitors ever show up and yada, yada, yada. We'll go through a few. So first of all, being in water is actually really good for surviving because water's a really nice equable medium. It's good at maintaining whatever heat it's got, particularly if you're in the sea. Freshwater far less so, but if you're in the sea, it's this vast amount of water. It's never going to warm up too much or cool down too much, or at least if it does, it's going to take a much, much longer to do it. And you can move. If the place you're in isn't very nice and you're in the middle of the ocean, just keep going. There's very few barriers. Whereas if you're on land, if there's a mountain or a river or a forest or a desert, then you just can't go. And you can't go very quickly. So being in water is good. Being on land is bad. Flying is quite good because you can travel long distances in a straight line. But the pterosaurs
that obviously didn't.
But all the pterosaurs went. So the first thing is being on land versus being on water, or in particular the sea. And the second big one is being big versus being small. So if you're small, first of all, you can potentially find a place where you can shelter, what we call micro-habitats. It might be really cool now the sun's blocked out. Well, if you're a dinosaur size, there's not a lot you can do to fix that. Whereas if you're mouse size, you can make a little burrow and you can hide in that burrow, which will keep the heat in. And, that will help. Secondly, you don't need as much food. If you are that little mouse and you run out occasionally and find a couple of seeds, that might be enough to keep you going for quite a long time. You weigh 20 tons, you need a lot of food. And remember, it's not just individuals, it's entire populations. So you need hundreds, if not thousands of 20-ton animals all finding enough food to keep going for years, potentially decades. You can see where that problem comes along. And that's probably a big problem for the pterosaurs. Most of the pterosaurs at this point were somewhere between 3, 4 and 10 metre in wingspan. Whoa. These are big animals. But it means that, they're going to struggle to keep going.
That's the size of a small plane. That's ridiculous.
Yes, they are.
Yeah.
Right, but that's why, despite flying, they've then got a secondary problem, which is they're really big. So being small is really good for quite a few ways, and there's some other ones too. Populations, again, having a population is important. Again, what would feed 10 mice wouldn't even feed one dinosaur. In fact, what would feed one dinosaur might feed 10,000 mice. And if you're small, you reproduce fast.
Oh, yeah.
Right, so more babies, higher population, that means more genes, more variation, more possibilities for natural selection to act on that one of you is a bit more resistant or a bit better at dealing with the cold or is a bit better at finding food, etc., etc., etc. So dinosaurs basically have none of these things to their advantage. They're relatively big, they did grow fast and they had a relatively high number of babies, but it would take them years to reach sexual maturity. They're big animals and they're living on land. So that's really quite limiting for them.
And this would explain also, presumably, why birds would have survived a bit better than dinosaurs, simply because of their size.
Yeah, so some studies have suggested that, perhaps slightly contrary to what I've just said, the birds that were really good flyers, rather than more kind of chickeny stuff, which could fly, but were, burst flyers to get up into trees or get away from danger rather than long distance flyers. It's that chickeny kind of body shape which actually survived particularly well. In fact, those were the ones that tended to survive. But again, they do fit those other categories. They're nice and small. They're probably good at finding places to hide. They probably don't need to eat that much, etc., etc. It's a bit of a surprise for me, at least, that some of the, big soaring birds and big wingspan ones, you think they'd be able to just fly around and find somewhere safe to land. Similarly, some of the big pterosaurs you'd think might go, flying a few 100 miles is trivial for them.
The dust could have hurt their lungs when they were up there.
Probably things like that too. But immediately you see why really big things, so again, lots of the marine reptiles, even though they're living in the sea, are going to go. Lots of the big fish and lots of the big sharks and stuff like that are going to go. The dinosaurs, the pterosaurs, various others. You see why things like crocodiles might do pretty well. Low metabolism, don't need to eat a lot. in water, can get around. That's pretty good. But then there's some oddities. So amphibians, we know, are horribly vulnerable to air and water quality and do really badly in polluted environments. And you'd expect lots of pollution from all this kind of stuff going off. And yet they survive worldwide. Frogs and newts and toads and salamanders and caecilians and all their other gribbly things basically did okay. I'm sure they took a pummeling. Their fossil record is not great, and that obviously doesn't help. But the fact that they survived on basically every continent and are still very diverse suggests that it wasn't necessarily an enormous problem for them. Certainly they didn't get wiped out on any big continent in a way that you really might expect.
It's very hard to imagine newts and frogs with any sort of, they're made of jelly babies, aren't they? Pretty much. So.
Yeah, it's the porous skin just makes them, really vulnerable to this. They can't keep this kind of stuff out. And then the other flip side of that is, well, why did some things go extinct that probably wouldn't? So we talked about, little ground-based birds that probably couldn't fly particularly well and certainly weren't flying big, long distances, were some of the groups that survived. Well, we have a bunch of dinosaurs like that. We have the small dromaeosaurs and troodontids and alvarezsaurs and things like this that were not very big and were feathered and didn't need to eat very much and probably could have tucked into a burrow or to a bole of a tree or something like this, and they all go.
You think the scavengers would do very well for the first sort of year.
Well, initially, yeah, that's the problem. It's got to keep working, but it's odd that they go. But of course, the other thing is, again, luck. Maybe they're just unlucky. Maybe there's some quirk of their evolution that obviously we can't tell from the bones. They were particularly vulnerable to air pollution for some reason. But also, we don't know how well these things survived. So periodically, you get enormous excitement in the press and occasionally even in the scientific literature because someone thinks they found some dinosaur bones after the extinction event. I'm not aware of any of these that have actually survived the test of time. So usually these are what are called reworked fossils. So in other words, they're from below the extinction level and something has moved them up. So the bit of ground they were in eroded, broke down, moved them. Well, usually they've got to come up, of course.
Yeah, but landslide can push other things up and you've got tectonic actions.
Roots of plants are known to lift things up. Burrowing mammals will dig a little burrow and then that can allow things to float up or move or shift and stuff like this. So
burrowing mammals through bedrock is pretty impressive, but...
Right, but again, you go to somewhere like Mongolia, which we talked about a lot in recent episodes of the Velociraptor and Protoceratops, and it's really sandy stuff. I mean, I've pulled fossils out of the ground by literally just pulling them out.
That's weird.
It's virtually just sand. Yeah, I know.
That's
it is
like
weird.
Those rubbish kids' toys where you think this is nothing like excavating a dinosaur, where they literally put some plastic bones into some sand pits. But is that what Mongolia's like?
In places, yeah, there are bits you can basically just pick them up out the sand. Where I've done a lot of stuff in Canada, so I took a photo of this. Unfortunately, it was a rubbish photo and I didn't pay attention to it, but I managed to sneak it into a Guardian article. It's a really nice example of this in the Canadian Badlands in Alberta, where basically you get these like mini sinkholes where the ground so water fills in, it kind of forms a cavity and they sink in. And what regularly happens is things like deer fall in. And then they die, and then the sinkhole collapses, and then it erodes. But what that means is, what you get coming out the hillside every so often is a 70-million-year-old dinosaur bone with a 10 to 10,000-year-old deer or bison bone coming out of the hill at the same time. But of course, they were laid down 70 million years apart, basically. But you can get weird things like this, and then of course people will misinterpret that, and it's very easy to do.
I mean, you say
so.
Misinterpret that, but I think this explains reindeer and flying reindeer and everything else somehow. This is what I'm going to make an alternate theory. Got evolution wrong, and actually it goes backwards as well as forwards.
So curiously enough, the creationists love this whenever it happens. But of course, it really doesn't change anything because there is no particular reason to think that there weren't some dinosaurs somewhere that survived this. Obviously not in the long term, because otherwise we still have them, or those
Loch
reports
Ness
from Loch Ness,
Monster.
or Afro Mokele Memembe, or whatever it is, would have a lot more credit. But the Earth is a big place that has many continents. I do not think it entirely unreasonable that there was a Lost Valley effect, or an island somewhere that a small population of dinosaurs was actually fine for 10,000, 100,000, 10 10 million years somewhere. But you're now talking about a dot on Earth that we need to have fossils from at exactly the right time to find it. And the odds of that are basically nil. And that wouldn't stop the fact that, to all intents and purposes, the dinosaurs, brackets minus birds, went extinct in the KT extinction. But finding dinosaur bones more recent than that really doesn't overturn the extinction event, and it sure as hell doesn't somehow disprove evolution.
So all of the birds, just to clarify this, birds did evolve quite far back before the end of the Cretaceous.
Yeah, we've not done bird origins in detail, but yeah, there's this idea that kind of dinosaurs turned into birds at the extinction, or the extinction somehow produced birds. Birds were around from the middle Jurassic.
Oh, wow. So they were tweeting back
then. So 165 million years old.
That's pretty good.
They were around for 100 million years before the dinosaur extinction. This is not a... Here comes the meteor, quick, fly! Which, you sort of get at times, is the impression that people give. No, nothing like that at all. Birds had been evolving quite happily, doing lots of interesting and different things for an extended period.
Cool. Okay, so we've established that massive meteor impact, bit of volcanic activity, massive amounts of climate change, everything starves, can't survive anymore, apart from the things which are very adaptable, smaller, reproduce fast, and are just cool. And lucky. Let's just underline lucky.
Yeah, it really is important, and yeah. I think that gets overlooked. These things on average will tell you what will probably survive and probably won't, but luck's a big factor.
It's a bit like the Hunger Games, and all the highly trained ones all get killed quite early on. Anyway. Just out of luck. So, okay, let's talk about the best ones, right?
The reasons they didn't go extinct.
Well, exactly, because you do have a lot of really cool theories, mainly because it just wasn't believed. I think we've mentioned Lyell. I don't know if we mentioned Tate as well.
We have mentioned Charles Lyell.
Yeah, we have mentioned... but we mentioned Charles Lyell before, because there is this idea of science of geology. You have these guys look around the planet now, and they see how erosion works and the gradual meandering of rivers, and they therefore put that back in the past. And the idea of an unusual once in a lifetime / once in 100 million years event, is just completely ridiculous. And so, I mean, that's why the meteorite idea was poo-pooed a lot, wasn't it?
Yeah, I think so. Well, I think the main reason the meteorite idea didn't take off is kind of how it came about. So this was... Famously, there were 3 or 4 people involved, but famously the Alvarez father-son team. So Alvarez was I think a Nobel Prize-winning physicist, and his son was a geologist who came to his dad with this problem of they'd been looking at these clays on the KT boundary and spotted there was loads of iridium and other weird things, and he didn't know what it was. And his dad went, well, that's what you get in meteorites. And they went, oh, there's loads of meteorite rock at exactly the point of the extinction. That could explain it. And they published a paper basically with something like 2 or 3 data points and went, here are 3 dots on Earth that all show iridium at about the right time. Therefore, meteor killed the dinosaurs. And you can see why, even in, I think this is the early 80s, even in the early 80s, 3 data points is not a lot of data. And that's a hell of a jump to make from 3 data points. And quite probably young geologist and dad who's a physicist and not even a proper paleontologist to come in and just tell us that we've got it all wrong and it's meteorites. You can probably see why it didn't go down very well. Of course, they're completely right.
I like that, though. I like the fact that, some sort of tin pot, people can actually change the science. And it takes a while to change the science.
Well, hardly tin pot, but you can see why the old guard would be very resistant to someone from a completely different field coming in with his son and going, we'll tell you. They're right.
3 data points. Yeah. I like that.
Yeah, pretty much. Extinction was barely even recognised as a thing when dinosaurs first appeared. In Western scientific culture, people were still running off the Bible, and everything that was in the Bible was still around now, and God wouldn't allow one of his creations to go extinct. So these things that we're digging out the ground must still be around somewhere.
Well, What about dodos? I mean, really, they're not paying attention. Dodos, they died at what? It's like late 17th century. That's...
Yeah, I know. Right, but I guess the counter-argument to that is we don't know they're not still around somewhere else.
That's true.
Was perhaps some of the thinking. So it was the famous French anatomist Cuvier who basically made the case, and they say proved extinction. I think that's probably not quite true, because it's almost like proving a negative. It's kind of impossible. But after Cuvier, people accepted the idea of extinction, but it's still pretty new. And yeah, certainly in the Victorian era and, Darwin's time and before, people were looking at these things and going, well, something must have happened. Why are we digging up all these reptiles absolutely everywhere? And in some way, the reptiles went, and now we've got mammals. So what was the thing? And right the way through into the 1960s, let's be quite honest, people, it became almost a magnet for cranks, to be quite honest. So in addition to some fairly reasonable scientific ideas, which were not particularly great, came lots of particularly insane ones put forward by any old people.
I just want to underline, before we get into these insane theories, that a giant rock coming from space and hitting the planet is an insane theory. It's correct, but it still sounds insane. That's
also true. When you talk about this kind of stuff, it's very easy to go, oh, well, that's easy with the benefit of hindsight. And it's like, that's true. And science has developed a lot. We have far more knowledge, etc., etc. But with at least some of these, even with the lack of, even lacking all the number of dinosaur species that we know now and all the other species and vast advances of science, they just fly in the face of what limited data we even had then. So you have things like flowers. Flowers evolve, and dinosaurs aren't used to dealing with them, and they ate them, and they were toxic in some way, and that's what killed all the dinosaurs.
I heard that they all had hay fever and couldn't breathe properly. That's what I heard, because they couldn't reach to blow their noses. T-Rex couldn't reach his nose.
So, you get ideas like that, and the problem is you take one look at that and go, okay, then what killed the marine reptiles?
Underwater flowers.
Well, right, and why could the dinosaurs not hack this and the pterosaurs not hack this, but the birds and mammals were fine? Even as people didn't know that birds were dinosaurs then, but we knew that birds were around then and had survived. So it's why it's this automatic selection. There's a similar one. Oh, the mammals started eating all their eggs. Okay, but again, even if you didn't know the dating or anything like that, you knew dinosaurs had been around for a massive period of time, and they'd been lived alongside mammals that whole time, so why was it suddenly now a problem? Right now, worldwide, every single dinosaur everywhere suddenly couldn't lay eggs. But the turtles and crocodiles did fine, that also lay their eggs online with similar shells in similar nests. And again, the marine reptiles that were live-bearing, they all died too. It doesn't pass the first 5 seconds of thought based on the data that you have. And there were, endless ones of these. They got too big and too stupid, even though that later dinosaurs were actually mostly smaller than some of the earlier dinosaurs, because the biggest ones were Jurassic. And we even knew that then, that the sauropods were Jurassic, and we didn't tend to find them in the Cretaceous. So that idea immediately flies in the face of the 4 or 5 data points that you've got. They as a lineage, they forgot too old and too stupid and couldn't breed anymore. They forgot how to breed.
That's brilliant.
It's also just...
I'm sympathetic with that, I'm getting older now. I understand that, so it's a logical...
But again, it's all dinosaur species everywhere simultaneously suffered from this problem.
There was some Viagra back then.
And again, the crocodiles didn't, and the turtles didn't. It's kind of painful. And this is the other thing, so you mentioned that, all these theories, inverted commas. These are not theories. These are at best ad hoc hypotheses. A theory is a body of evidence that has undergone testing and proofing. This doesn't survive the first observation.
To clarify, I am pretty much all the time using colloquial language, not scientific language, just in case anybody wants.
I know you are, and I'm not trying to have a go at you, or indeed any of our listeners.
I'll just make it clear to the listeners, I understand the difference between a theory. I understand that the theory of gravity is pretty real, as in certain. I'm not one of them.
But it is a problem, and again, you come across creationists and literalists of various forms who use that lack of clarity to go, oh, well, evolution is just a theory. Because colloquially we go, I have a theory that next year if this team buys that player, they'll win. And it's like, that's not the same as scientific theory. And that's fine in context, but that's not what you mean. As you say, gravity is a theory. I can't remember who it was. I want to say Sagan, but I'm sure it wasn't Sagan. But there is a quote from a scientist like, if you want to test that gravity is just a theory, you're welcome to jump out of my office window. I'm on the 15th floor.
Yeah. Yeah, not a good idea. Yes.
Or potentially quite a good one. Depends who takes up the challenge.
No, because ignorance is something that we can change. This is the thing. Gravity and the effects of jumping off the 15th floor is something you cannot change. So it's a bad way to test things. Don't do that, people.
I was going to say, if this had a video, there'd be a little thing scrolling across the room. Very rapidly, Dave Home does not advocate jumping out of a 15-story window. We accept no liability for jumping out of a 15-story window.
Do not do this, in fact. What other hypotheses were there that were more reasonable than that? Because they can't all have been. Until we discovered the meteorite, what's the main theory?
Oh, honestly, I don't know.
It's just the silly ones, you see. You only remembers the silly ones.
Yeah, you remember the ridiculous ones and not the realistic ones. I mean, I think people had found the Deccan traps fairly early on and had thought that cold of volcanology. I mean, there were somewhat more serious ones about plants, you know, not so much like, oh, they're hay fever or they all got poisoned, but you can conceive in a less, let's say, colloquial and over-exaggerated idea that this could cause fundamental ecosystem shifts and ecosystem collapses. And if lots of species can't keep up with that, then you're going to lose a whole bunch of things, and dinosaurs would be kind of first among that. It still doesn't really explain the marine reptiles very well, but that extinction was more on land than in sea. You know, that would be a pretty good start. Temperature was another big one. Remember, all these things that at least people were focused on were reptiles. So temperature got too hot or too cold. Suddenly their eggs don't incubate properly. That's obviously going to really impact. Again, I think people thought that was pretty credible at the time, but again, it's this weird, really absolutely everywhere at once simultaneously. There were no areas which were a bit warmer or a bit cooler, you know, or no bits of the planet that weren't protected from that because they happened to be at altitude or wherever, or things didn't just move. And of course, you know, they could dig their nests a bit deeper or a bit shallower or just move down the road a bit to where it was a bit less shady to warm up. It seems a bit odd that it would be... You could see how it could be extremely bad, but instant mass extinction globally is a tough one. I don't think there were too many really credible hypotheses or even theories that were knocking around prior to the bolide one. And then, of course, in hindsight...
It seems obvious.
Well, not so much seems obvious, but it is very instantaneous. It is global. You do need something like that. And then coupled with, you know, the Alvarez data and, of course, vast amounts of research since really does back it all up. You know, you've got iridium absolutely everywhere simultaneously, and it's thicker in North America and thinner in Europe and thinner again in Asia, representing going further and further out. We've now found the impact site. You know, the dating lines up absolutely perfectly. It's sunk into the consciousness as this absolute, you know, moment in time, and quite correctly, really. Yeah. And yeah, as you kind of say with Yellowstone and the Tambora event and these other things, it's like, I think there's this, you know, there is a kind of lingering thing. It's like, is that going to happen again? It's like, yeah, maybe.
I have a question, which you might not know the answer to, but I'm interested.
17.
If we're, exactly, 42. If we're saying that the reason that the dinosaurs died out as a group is because they were larger, they couldn't survive, they couldn't keep up with the climate change and everything else because they couldn't adapt fast enough. What about the larger mammals and the larger birds? Because I know there were big birds back then. Or did they adapt? Or am I wrong in that? And actually, that things like terror birds actually evolved a lot later than I imagined.
The terror birds are way after.
Yeah,
so
okay.
Yeah, they're a new derivation that came well after the extinction. You know, we had some... I'm trying to think of the biggest birds we had were probably only a couple of meters wingspan, so small compared to the pterosaurs. You know, about what you have today, you know, big buzzard or big gull or something.
No ostriches yet.
No, nothing... Well, Ballure we talked about, so this...
But that went extinct.
Possibly, yeah. I mean, that had gone already. But you know, if Ballure is truly an early flightless bird and not a weird dromaeosaur, and that is still uncertain. I think most people think it is a weird early flightless bird. That evolved pretty early on, and that was Velociraptor plus, bit bigger in size. So that's a very good-sized bird at that point. But yeah, still nothing like ostrich size, moa size, terror bird size, or anything like that. And again, big mammals. The biggest mammal that I think we know of from the Mesozoic is a thing from China called Rapenomamus. I've been lucky enough to see Rapenomamus. It's like big badger sized, but that's the largest mammal in the Mesozoic.
There's no whales
and in the Cretaceous, I don't think there's anything that size. No, whales turn up fairly quickly after the extinction. Perhaps not surprisingly, because now you've got an ocean devoid of large predators. One last thing, not to touch on dinosaurs, but this problem of gaps in the fossil record, we don't capture everything. So there are a couple of bones that suggest that part of the lineage that give us modern chickens and ducks was around in the Cretaceous. You may have been Cretaceous ducks.
My far side self is so happy that there might be Gary Larson cartoons might be real.
With a little duck and a dinosaur. Yeah. But
can you imagine a mallard walking around next to a T-Rex? Oh!
But, there's some big mammal ones. The really big question is, had primates split off from their nearest ancestors prior to the KT extinction? If that's the case, there were Cretaceous primates, which is extraordinarily cool to think. And similarly, bats appear almost fully formed and batty really not long after the KT extinction. So were bats a KT survivor, or did they evolve incredibly quickly afterwards?
It would make sense that, suddenly all these mice need to get about quickly.
That virtually is the extinction's coming, fly argument.
Exactly.
But in terms of, dinosaur ecosystems and what we think of them as being, these are massive uncertainties. The primate split, the bat split, these are done off molecular clock dating, so looking at the genetics of modern species, trying to work out how different they are from each other. We know certain things evolve at a certain rate. You can track that back, and the suggestion is maybe these things split in the Cretaceous. But yeah, there is the possibility, and I use that word very carefully because we don't even know if they were around, and if they were, they had only just begun evolving, and yada, yada, yada. But you could have had ecosystems with a T-Rex and with a Triceratops and with your dromaeosaurs and ducks and monkeys, or at least lemur-like things, and early bats. And the possibility of that is fascinating because, again,
paleo artists are listening to this, getting their pens out.
I think the paleo artists no, but it's like that as a possibility exists. And of course, it's one of those lovely questions. I think we get quite a few of these in paleontology, and I think they're particularly interesting because either explanation is fascinating. Either these things were around in the Cretaceous and they survived this mass extinction, in which case, what were they doing? Where were they doing it? How were they doing it? How did they survive? What did that mean for their evolution and how they diversified and then spread around the planet? Or they didn't, in which case they appeared afterwards and appeared very, very quickly and evolved very, very fast, more than we would normally expect when other things weren't necessarily doing that. And so it doesn't matter which of the two is correct. They're kind of weird and really, really interesting.
It'd be a lovely idea if evolution could happen that quickly. There's a gap here, let's just fill it.
Well, I mean, in theory, maybe. If you have there's this idea of what's called hopeful monsters, which is a Stephen Jay Gould thing, which I don't think worked very well in the way that Gould described it, but I think a version of it is, if you have a landscape where you've basically removed most species, then any kind of mutation, which would actually might normally be very beneficial for you, is probably okay. It's like, slightly longer wings than your ancestors. Well, that might make you fly a bit better, but you know what? There's already a species which does that, and you're not as good as flying like that as that species, so you're soon going to be outcompeted and you're going to die off. Oh, well, none of those species exist anymore. So actually, despite the fact that...
It's a very capitalist view of evolution, isn't it? It's like, companies starting up and then other companies going, actually, we've got a better product, and then this one's been around for longer, so therefore it's better.
Yeah, to a degree, but I guess it's the same principle. That landscape is free. If someone went through and knocked all the banks out, then any kind of form of trading money and loaning and working, even if it was completely novel and didn't do it like any of the others did before, would probably work. And you'd probably expand quite quickly because there is, in the capitalist terms, there is a market for that.
It's a gap in the market there. Fill it. Put your penguins in it.
But it means, in post-extinction, we do think once the ecosystems start to recover, because obviously if there's very little food, nothing much is happening. But once the stuff kind of cleans itself up...
Once the plants go, oh, the dust is gone, let's have a bit of...
Yeah, pretty much. Then you're in a world where there's suddenly now a lot of food and not a lot of things are eating it. And so, yeah, if you're some small... if you're the only little mousy mammal... and you breed and breed and breed, and with a few generations, a few hundred of you, and some of you climb a bit better, and some dig a bit better, and some run a bit better, and some eat bigger things, and some eat smaller things. You can see how very quickly that's going to turn into 5 species, and 10 species, and 50 species. In a way that wouldn't if you already had 50 other species of mammals doing that, and you dropped our new little mammal in.
Can't fly up here. Will attack you, and you can't climb our things. You've got barbed burrows already here.
Yeah, pretty much.
There's just no competition. Interesting. So that is a sort of, zoological side of the mass extinction. But I thought what would be really good is if we spoke to somebody who knows a bit about, the astrological? No, that's wrong, isn't it? Astronomical. Oh, God. Anyway, you can see we need help with the big, great burny, fally sky rocks. So we've got down the line the magnificent is Phil Plait. He is the Bad Astronomer. You'll know him on the internet for it, and he wrote a book called Bad Astronomy and is awesome. So, yes, please welcome, it's Phil Plait. I would like to ask you really about sort of meteor hitting the Earth, the likelihood of that happening, the likelihood of that being a, catastrophic event that kills everything on Earth, and if that will happen again, type openness that you can better than I can ask the question.com.
No, I think you asked it fine. And in fact, I can give you a numerical answer. The chance of a large asteroid impacting and causing a mass extinction is 100%. There's no question about that.
Well, that's because it's already happened.
Yes, I mean, it's happened numerous times, and you don't have to go very far to find impact crater evidence. And if we do nothing about it, the universe, will throw another one our way. Now, it may not be for 100 million years.
That was, I think, the bit that we were really heading towards.
Yeah.
What's the likelihood of it happening again soon?
Yeah, so it's not an ill-posed question. It's just, you have to qualify it a little bit and say, okay, yeah, what are the chances of an asteroid hitting the Earth? And the answer is, well, we get hit by 100 tons of material every day, every single day. But it's tiny, little grains of sand, maybe something. We have standard sizes for these. We have dust grain of sand, grapefruit, or softball. Prefer grapefruit. A lounge chair, car, truck, building, and then wave bye-bye. Anything bigger than that.
Building covers quite a... I mean, building alone covers 3 or 4 orders of magnitude.
Shed, Trump Tower.
Yeah, well, you can specify and say, it's a 100-story building. Like that's really bad. 10-story building, the Chelyabinsk impact in a few years ago in Russia, that was 19 meters, so 60 feet. So whatever that translates into stories. I'm not sure stories is a standard thing, but 5 stories, something like that. So the question isn't, will it happen? The question is, well, can we prevent it? And the answer is yes, if we have a mind to. The other question is, how often does it happen? And then even that question, you have to say, how often does that happen per size? So like how long do you have to wait for a grain of sand to hit the Earth? The answer is several have already hit us in the time it's taken me to say the sentence, versus something like Chelyabinsk, which we think happens more on the many decades scale. But a lot of the times they happen over the ocean or someplace where, Antarctica or someplace where there isn't anybody and you don't see them. We have satellites that track that stuff. We have microphones which track that stuff. They listen to infrasound, subsonic frequencies, and a bomb or an exploding asteroid or something like that makes a certain sound. And these microphones can pick it up. It's pretty cool.
All right. I thought for a moment that in my head, I just thought, so you can hear them coming in, forgetting that vacuum, space is vacuum.
Sizzling sound.
But also, I imagined it as like some sort of like giant alien chucking them towards us. Just like, God's just going, go on, left a bit, right a bit. There you go, dead on. Boom.
Well, now I'm thinking about that. As it's burning up, I mean, these things are moving at, 40, 50 kilometers per second. They are screaming in.
That's the thing. As they're coming in, even if you're just waiting till you hit the atmosphere, there's not a lot of time to hear the and
yeah.
oh, hang on, better get out of the way of this one.
And they're burning up 100 kilometers up, 60 miles up, and so it's hard for the sound to be transported. So if you look at the Chelyabinsk videos, which basically I think everybody has.
Sorry, just to be clear for everybody who hasn't, Chelyabinsk, because when it was in a Russian town, you see all the dash cam of this fireball going across, and all the windows smashed, and everybody got cut up because they went to the window to have a look, because you would. But that's what we're talking about here, isn't it? It happened in 2013. Something like that? Was it?
I think so, yeah. February 2013.
Cool, thank you. Sorry, just to clear it up for idiots like me who don't know the names of stuff.
So, and the thing is, about that particular impact from a 19-meter chunk of rock that was very fragile, if you had held it in your hand, and you can get these meteorites, it's not a very dense rock, and the overall, what they call the main mass, the thing that came in, had a lot of cracks and fissures in it. And you can tell that because in the video, you see this pop, 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 these flashes. And that's the rock actually breaking apart, increasing its surface area so you get more brightness. So you get these little explosions, and then it just basically, when it gets to a certain size, it's ramming through the air so hard, it just basically releases all of its energy all in one big burst, and you get an explosion. But when you see that video, it's making a long track across the sky. This thing came in at a very, very shallow angle, and a lot of them will, on average, at a 45-degree angle. This one was even lower. So even then, you can see how quickly it moves across the sky. It's terrifying. It crosses the sky really rapidly, and you got to realize, an airplane takes several minutes to cross the sky, and the airplane's only 5 miles up. This asteroid was 60 miles up, so it was much, much higher, coming down, and it exploded at different elevations. But, the explosions you can hear on these infrasound, but I'm wondering if it just came in, would you hear it with I don't know, I guess the shock wave would make us, I was
going to say, isn't it traveling faster than the speed of sound?
By a lot.
Right, that's what I was going to say, by a very considerable margin. And
yeah, that's why they call them hypersonic. I mean, supersonic is faster than the speed of sound, and hypersonic is really faster than the speed of sound.
Hypersonic's 5 times, isn't it?
Or more, I think. Yeah, and I don't think there's really an upper. It's just an adjective. It's not really a scientific.
Plus.
Yeah. So I don't know. I mean, Izzy, you got me thinking about that, and I wonder. I mean, we can when they burn up too, they ionize the air. They strip the electrons off the air, and that reflects radio waves. And so you can hear meteors, and there are websites you can go to where in shortwave the radio waves will bounce off that vapor trail, and you can hear these and all these weird sounds as the radio waves are bouncing off the plasma and all. It's really cool. So I don't remember what your question was. Now we're just off.
It doesn't matter. It answered it perfectly. Well, the other thing is, what is the difference to life on Earth? Say a big asteroid comes in with it basically going in at 90 degrees and hitting the Earth versus 45 degrees and exploding above the surface.
Well, that would be for small ones. So anything smaller, well, and it depends. Here we go.
Sorry.
So something like Chelyabinsk, which was 19 meters across, that's pretty small. As big ones go, that's small. As small one goes, it's big. So there you go. You can write that down if you want.
Thank you.
It's a big small one, but a small big one.
Yeah.
Yeah.
So anything at that size, even if it's made of metal, at about that size, metal will reach the ground. Rock probably won't at any angle. There's too much pressure. It breaks the rock up. It's ramming through the air so quickly, it's like hitting a wall, and it crumbles the rock and it falls apart. But at some size, 30 meters, something like that, and it's made of metal, it'll reach the ground, like in Meteor Crater in Arizona. Here in the United States, and that's a crater that's almost a mile across. So that's big. It's very impressive. I've been there. It's a gigantic hole in the ground. And so something like the Dinosaur Killer, which was 10 kilometers across, 6 miles, doesn't matter. Straight in, angle. If it's made of popcorn versus iron, it hardly matters. Well, I mean, it matters. But at that size, you're talking about an extinction level event no matter what. And bigger than that, you look at the Earth, and what was it? 75% of all species, land and marine, were wiped out by this.
Yeah, give or take. It was actually worse on the land than it was in the water for that one, even though it hit the water, because obviously what it really did was kill a lot of terrestrial stuff. So you got mass extinctions. Ultimately, whatever the causes, what really kills stuff is climate change,
right?
Which is a bit of a warning for anyone who hasn't worked out the current situation yet. And water, obviously, is a really good equalizing medium. It can suck up a lot of heat and be resistant to a lot of cold and all kinds of other things like that. And you can move freely in water. This is the other thing, if you're an animal and it's really cold where you are and you want to go somewhere else, there might be a river in the way or a mountain range in the way or something else. If you're in water, you can, particularly if you're in the sea, you can just go somewhere else. It's fairly ease of passage between different areas, and so that massively boosts the survival of things.
Right. So there you go. And you lost a lot. Certainly in the shallows was worse than in the deep areas, and on land it was catastrophic. Well, I guess the point I'm making is it would take something a lot bigger than 10 kilometers across to kill everything. And, there are bacteria that are found deep underground and in ocean sediment and all that stuff. So you give it a billion years and life will rebound. It'll bounce right back in another eon or two.
Yeah. Yeah, being able to kill absolutely everything, I think, you're getting on the point of having to destroy the planet.
Well, yeah, you need something to sterilize the crust, to raise the temperature of the planet to the boiling point.
Right, but even then, you've got things like resistant tardigrades, which you can put them in nuclear reactors and heat them to 150 Celsius, and they're fine.
Yeah, but even then...
I mean, you didn't ask them personally. I bet they're saying they're not fine. I bet they're saying, actually, I quite like it at room temperature. Thank you.
I like it up here at my elevation, but I wouldn't want to be at the top of Mount Everest. So, a tardigrade, I don't think anybody's ever said, yes, we can put them in a nuclear reactor, but do they enjoy it?
Well... Probably not, but the point, to make that kind of point or to argue that point of, just what would it take to sterilize the planet? There are some things which are unbelievably resistant, not just because, as you say, they live in weird places and it's hard to get down to bacteria living in uranium mines and at the seafloor, but there's also stuff which is remarkably hard to kill no matter what the hell you do to it. And when you put those two factors together, it's probably really tough to wipe out everything.
Well, I would say it's easy. It's just rare. You take an asteroid the size of...
You need a really big asteroid, which will be really, really rare.
Drop the moon on the Earth, and nothing's going to make that.
Does it have to be moon size? What's the biggest... What asteroid size would do it?
I don't know. The size is important. What it's made of comes into some amount because it's just mass. You double the mass, you double the impact energy. But if you double the velocity, you get 4 times the impact energy.
Ooh, so faster is better.
So speed is better. That makes comets a little bit more dangerous. Because they tend to fall in from the outer solar system, so they're falling for longer, and they come in at higher speed. And comets can be quite large. Hale-Bopp, which was in the 1990s and visible to the naked eye, everybody of a certain age probably remembers that because you could go outside and just look up and see it. That was 30 kilometers, I want to say, in size, which means it was 3 times the diameter of the asteroid that wiped out the dinosaurs, which means the volume goes as the cube of the radius, which means it was 25 or 30 times bigger, the volume. So that would have had...
And then faster as well.
That would have wiped out everything. And we didn't even discover that comet until 18 months before it passed the Earth. If it had been aimed at us, that would have been bad. On the other hand, things are a lot different now. That was 25 years ago. We're a lot better at spotting these things now. We'd have, 3 years warning before every animal and plant was wiped off the face of the Earth now.
And not to drag this on endlessly, because I appreciate you have other things to do, is how exactly do we stop a 30-kilometer across comet at 3 years' notice?
You don't.
Right.
Yeah, you don't. I mean, think about that. That's bigger. That's substantially bigger than any mountain on Earth. It's like 10, 20, 30 times the volume, something like that. I don't know. Have to do the math. But you don't. But you don't have to worry about those because and people do. I know I get email all the time who are concerned about this, and that's because we don't communicate the numbers very much. It's very easy to say, asteroid coming in, get Bruce Willis. But then somebody says, well, yeah, what are the odds? of an asteroid the size of Chelyabinsk coming in? The answer is, well, a couple of times a century, and it's not that big of a deal. Typically, I say it exploded over a city. A lot of people were hurt. I'm not minimizing that. What I mean is, on a species level, something like that isn't going to affect your populations. On the other hand, something a mile across, that's going to start having global effects, and then much bigger is bad. But the bigger they are, the more rare they are. Like I said, we get hit by grains of sand literally all the time. Something the size of a building is much, much more rare. Something smaller is easier to prevent from hitting us. One way is literally slamming a rocket into it, and that changes its velocity and its speed and its direction. If you do that early enough, it won't hit the Earth. And what I say is, it's like this: you're crossing a busy road. You look, well, you're in England. You look right, you look left, you look right. In America, you look
we look both ways.
Yeah. And if you see a car way down the road, you have plenty of time to cross that road. If it's 10 yards away from you, it's going to hit you. There's nothing you can do. So the farther away something is, the more time you have to, if that car, when it's far away, sees you and brakes a little bit, or even accelerates a little bit so that it passes you before you cross the road, that's legit too. So all you have to do is change the velocity of these things a little bit if you give it 10 or 20 years notice.
Because we're moving as well as they're moving.
That's right.
It's fine.
But even if one of us was still, and there's nothing still in space, the principle is, it's going to hit us. Its trajectory is intersecting our trajectory. If you can give it a little nudge so that intersection changes, you're safe.
Okay, so how good are those calculations? Because I'm aware that, the very enormous complexity of gravity across multiple bodies across extraordinary distances. And we're talking about hitting it with a rocket and only deflecting it a tiny bit. And therefore, my first thought is, if you've calculated that intersection wrong by about 0.001%, and then you nudge it with the rocket, you will now make it hit when otherwise it would have missed.
The 0.01% is fairly optimistic, I would say. I'd have to do that now.
I don't know. I'm just. Yeah. But just the idea that you can't calculate it that accurately, and therefore that nudge could do the exact opposite of what you intend it to do.
Dave, you're overthinking. There is a reason why humans have evolved to play snooker, and this is ultimately what will save us.
In a sense,
imagine
there's a fly in the bar, and you have a dart.
Yeah,
and it's like, well, maybe. If that fly is fitted with a radio beacon, and your dart has a mechanism on it that homes in on that helps a lot. Dave, your question is actually really good, right? You have an object that's, let's say, a mile across, which is a global problem. And I could talk about that for ages too, but I won't. So it's a mile across, but it's coming in at, 30 miles per second. That would actually be maybe a little slow, a little faster than that. It's crossing its own diameter in a tiny fraction of a second. And if you can get in front of it, if it's moving in a certain direction and you can get on that path, then you can maximize the amount of time you have to hit it, as opposed to sideways, where if you're running along a road toward a car, it's more likely to hit you than if you're running across the road, right? Your cross section is smaller. That's the point I'm trying to make here. And in fact, if you're off by a tiny fraction of a second, you're going to screw this up. And it may be that you push the asteroid, and this is a question that astronomers have been trying to get politicians to consider. The example I always say is, imagine you have an asteroid coming in and it's going to hit country A, and country B is the one who's going. You have international cooperation. Country B has the one that's designed the targeting software on this thing, and and then it still hit country A, or country A has the targeting software, and for some reason it hits country B. Who's responsible for that? How do you do this? And it turns out it's a political minefield.
But the thing is, country B may not be in a position to appeal.
Well, yeah, you hope. If the country shares a border, it may not matter. If it's across the planet, maybe you have 8,000-mile buffer. But that's an interesting question, and NASA and the European Space Agency are working on this, sending missions. There's a mission called DART, which is I haven't thought about the acronym in a while. It's like Double Asteroid Redirect something. I can't remember what it is. But there's an asteroid with a moon, Didymos, and that's an asteroid, and they have it has a little moon orbiting it that's much smaller, which I wanted them to call Epididymos, but that's my sense of humor. Thank you. And it's a great pun. But
Bonus
no,
biology
sadly,
joke. Excellent.
and I can't remember what it was given an official name recently. But anyway, this mission is going to slam into that little moonlet and try to, and there's going to be an orbiter that's going to measure everything and see how much it gets moved. And that's important. We need to figure out how to do this. It's been done once with the Deep Impact mission back in 2005. That was a NASA mission that slammed into a comet just to see if we could do it. And it was hard, but it worked more or less. And this one is the same thing. And see what happens when you hit an asteroid. Can you change its velocity by a certain amount? And what does that tell you about how much of a lead time you need to hit one to make it miss the Earth? Remember, the most you ever have to move this asteroid is 4,000 miles. It's the radius of the Earth. If it's coming in dead center and you move it 4,000 miles, it's a miss. So that's good.
Yeah, it's fine. We can do that.
So people don't need to worry too much, basically.
Yeah, I mean, if you've got a day's warning, you have to move this thing 4,000 miles in a day. That's probably not going to happen. But if you have 100 years warning, that's a lot better.
By 100 years, we can make it out that, we can definitely start a religious cult that will just make us all fine with being hit that far out. That's fine.
That might be quicker, easier, and cheaper.
Yeah, you need to look up the Millerites. I think I've got that right. There was a cult in America. It's been a while since I've read about this, so I don't remember the dates. I want to say it was 19th century, and they predicted a giant comet was going to hit the Earth, and it didn't. Which got named the Great Disappointment, which I love. That's very English, actually.
That rings a bell.
That rings a bell. Yeah.
The Great Disappointment, and then they predicted it over and over and over again, and it never came. And a branch of that became religion in the U.S. Oh my gosh, I'm totally blanking on this, but I should never have brought this up. But, I mean, there's a great Wikipedia page about this. You can read about it, and there's tons of information about this. So yes, Izzy, it's a good idea, and in fact, there's precedent. So go ahead, knock yourself out.
Yes.
Well, not just precedent, there's competition.
Indeed.
Well, there's always going to be competition for end days religious, but I think the Izzites has a nice ring to it.
Oh, yeah.
Nice. That does. I feel like wearing a crown. But I also want to point out right at the very end of all this, we will not talk about it because we've taken up way too much of your time, so thank you. But if we do get hit by a comet, always a chance of panspermia. Boom! It might kill off everything, but then regenerate life from the comet itself.
Yay!
Yeah.
Big thank you there to Phil Plait, and Dave, we're all gonna die. It's been a real uplifting.
I think we knew that to a certain degree.
I know, but it's all gonna be smashy, doom. It's everything's going to die. And change.
There's that phrase: life is a disease with a 100% mortality, which is
yes, that is true. But you see, in many ways, it doesn't matter if you and me and all of our friends and family die. It just matters that the species and all other species, and there's going to be a big rock coming from the sky sometime, and it doesn't matter even if it doesn't happen because the sun's going to expand and expand. Oh God!
Yeah,
happy days, everybody.
Yeah, let's not worry too much about the heat death of the universe just yet.
What? Oh, the heat death of the universe is horrible. You don't want to live forever, guys. Never wish for that, because that means all your molecules are going to be spread out miles apart forever, doing nothing.
Isn't that something like 1 trillion years away, though?
I'm still sad about it, okay? Anyway, but I'll tell you what, there's something you shouldn't be sad about, and that is becoming one of our patrons on Patreon. Yay! If you want to do that, we are releasing some extended interviews and that sort of things on there. We've also got a few extra bonus episodes on there, so do have a look at that. And if you want to buy our merch, please do that as well. But
someone did. People bought a thing.
People have been buying things. It's been good. So if you want to do that, do go to terriblelizards.co.uk, listen to the outro. There's a huge amount of bump with that. But yeah, just cheer yourselves up, guys. Be nice to things, because the big monsters from the sky are going to come and destroy everything that you know and love.
On the other hand, as far as we know, dinosaurs didn't drink alcohol and they're all dead. So if you do want to offset things,
Yeah, don't think it's going to help much. Anyway, until next week.
rawr.
Thank you for listening to the Terrible Lizards podcast. For bonus episodes and extra content, please visit our Patreon page. You can also purchase a mug, t-shirt, or a Terrible Lizard face mask from Redbubble. Go to terriblelizards.co.uk for links. Send us your questions. Email terriblelizardspod@gmail.com. Find us on Facebook and Twitter. Include the hashtag Terrible Lizards. We hope to bring you more and more, but we can only do that if we get enough listeners. So please like, share, leave a review and subscribe.